we're on math lesson 55. Make sure you've got your name at the top. Go ahead and do your power. When you're done, press play. Let's correct these together. 81 divided by 9 is 9. 27 divided by 3 is 9. 25 divided by 5 is 5. 6 divided by 2 is 3. 45 divided by 5 is 9. 9 divided by 3 is 3. 32 divided by 4 is 8. 16 divided by 4 is 4. 12 divided by 2 is 6. 56 divided by 7 is 8. 9 divided by 1 is 9. 42 divided by 6 is 7. 14 divided by 2 is 7. 28 divided by 4 is 7. 24 divided by 3 is 8. 40 divided by 5 is 8. 18 divided by 2 is 9. 72 divided by 8 is 9. 18 divided by 3 is 6. 54 divided by 9 divided by 6 is 9. 49 divided by 7 is 7. 8 divided by 2 is 4. 36 divided by 6 is 6. 12 divided by 3 is 4. 64 divided by 8 is 8. 4 divided by 2 is 2. 0 divided by 5 is 0. 24 divided by 4 is 6. 8 divided by 8 is 1. 35 divided by 5 is 7. 21 divided by 3 is 7. 20 divided by 4 is 5. 16 divided by 2 is 8. 30 divided by 5 is 6. 36 divided by 4 is 9. 15 divided by 3 is 5. 48 divided by 6 is 8. 10 divided by 2 is 5. 63 divided by 7 is 9. 56 divided by 8 is 7. Mental math, A says find the change back from $1 if you had 26 cents. 2 plus 7 is 9. 6 plus 4 is 10, so you get 74 cents. Back from 92 cents would be 8 cents, because 9 plus 0 is 9. 8 plus 2 is 10. C, back from 31 cents. 3 plus 6 is 9. 1 plus 9 is 10. D, how many years are in 1 decade? Remember, 1 decade was 10 years. E, Autumn paid $4 for a box of cereal and received 50 cents back in change. How much did the box of cereal cost? So she paid $4. She got 50 cents back. So what's 50 cents less than $4? That'd be $3.50. F, 4 meters is how many centimeters? Well, remember, 1 meter equals 100 centimeters. So 4 meters is going to equal 400 centimeters. G, choose a more reasonable estimate for the length of a banana, 8 inches or 8 feet. That'd be 8 inches. 8 feet would be taller than me. H, calculate 48 plus 29 plus 210. 48 plus 29 is 77. Plus 210 would be 287. Problem of the day says, Majid was thinking of a 2-digit number. He gave this clue. You say the number when you count by 3s from 3, 4s from 4, and 5s from 5. What was Majid's number? Let's count by 3. 3, 6, 9, 12, 15, 18, 21, 24. You say the number also when you count by 4s from 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And you say it when you count by 5s from 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. What was Majid's number? So it has to be in all 3 of these lists. When you count by 3s, 4s, and 5s. Well, is 6 in these two lists? No. 9, no. 12, no. 15 I see here and here, but I don't see 15 there. So we need to keep looking. Keep going with 3s. 27, 30. Well, I see 30 here and here, but not in this one. 33, 36, 39, 42, 45. I say 45 in both of these. But I don't say in this one because this will be 44, 48, 52, 56, 60. So keep going. 45, 48, 51, 54, 57, 60, 55, 60. Oh, I got 60 here, here, and here. So that number, sorry, you can't see those at the bottom. That number would be 60. Because I said it when I counted by 3s, when I counted by 4s, and when I counted by 5. My work is really, really sloppy. What you need to have is 60 here. All right? Go ahead and flip it over. Let's get started on our new concept. Today our new concept is prime and composite numbers. If we multiply by 4, we get 4, 8, 12, 16, okay? These numbers are the multiples of 4. That's what you're thinking when you're counting by a number. That's what you get with the multiples. Now, for example, the multiples of 6 would be 6, 12, 18, 24, 30, 36. The multiples of any counting number are the products when we multiply by 1, 2, 3, 4, and so on. So like 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Example 1 says list the first 4 multiples of 7. So think, what's 7 times 1? 7. 7 times 2, 14. 7 times 3, 21. 7 times 4, 28. All right? Example 2. What is the fourth multiple of 6? Fourth multiple of 6? Well, if we had 6, 12, 18, 24, the fourth multiple would be 24. Notice that's the same thing, let me sync my multiplication chart in here, as if we did 6 times 4. 1, 2, 3, 4. Right? So the fourth multiple of 6 is the same thing as 6 times 4. B says, what's the third multiple of 8? Or what's 8 times 3? 8 times 3 equals 24. So B is also 24. Example 3 says 12 is a multiple of which whole numbers? Well, a multiplication table can help us answer this. We can find 12 at these locations. 1, let me get a little farther out. 1 times 12, right? There's a 12 right there. 6 times 2, we can get it right there. And 3 times 4. Okay, so we say 12 is a multiple of 1, 2, 3, 4, 6, and 12. Why? Well, because 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. All right? Now, if you think about your multiplication table, the numbers at the top and on the side, those are called our factors. What you get in the middle is your multiples. So, the factors of 12 are 12 and 1, 6 and 2, and 3 and 4. All right, so factors, if we're finding the factors of a number, we're finding numbers smaller than 12. If we're finding the multiples of 12, we're finding numbers bigger than 12. Example 4, list the 4 factors of 6. Well, we know that 1 times 6 equals 6, and we know that 2 times 3 equals 6. So the factors are 1, 2, 3, and 6. So write 1, 2, 3, 6. Right, those are the factors of 6. Think what numbers multiply together to equal 6. Example 5. List the factors of 9. 1 times 9 equals 9, and 3 times 3 equals 9. So the factors are 1, 3, and 9. We don't need to write 3 twice. Factors are just 1, 3, and 9. And then 6 says list the factors of 7. How do we get 7? Well, 1 times 7, because any number times 1 is going to stay the same. Do we find a 7 anywhere else on here? 1, yep, 1 times 7. 2, now we skip 7. No 7. No 7. No 7. Here again, 1 times 7. So if a number only has 2 factors, 1 and 7, then that's what we call prime. Write in all capitals and put this funny star looking thing around it. Prime, all right? So prime number is a number that only has 2 factors. Let's look at example 7. Which of these numbers is prime? 8, 9, 10, or 11? Let's just write those. Get my book out of the way. 8, 9, 10, 11. Well, let's try 8. 1 times 8 equals 8. Are there any other numbers that we can multiply by and get 8? Well, yeah, 2 times 4. 2 times 4 equals 8. So 8 is not prime because it has 4 factors. 1, 2, 4, and 8. What about 9? Well, we just said it has factors of 1 times 9 and 3 times 3, so can't be prime. 10. 1 times 10. What else? Well, it's even, so we can do something times 2. 2 times 5, so not prime. What about 11? 1 times 11. Anything else that you can multiply by to get to 11? Nope, so 11 is prime. All right? 11 is our prime number there. Let's go on to our lesson practice. List the first 5 multiples of 6. First 5, so count by 6s. 6, 12, 18, 24, 30. 6, 12, 18, 24, 30. B says list the third, fourth, and fifth multiples of 9. Well, 3 times 9 is 27. The fourth multiple, 4 times 9, is 36. And the fifth multiple, 5 times 9, is 45. C, what is the seventh multiple of 8? Well, what's 7 times 8? 7 times 8 is 56. What is the last digit of any multiple of 10? 10 column multiples. What's the last digit? 0. Anytime you multiply by 10, you're going to get a number that ends in 0. E, what 2 digits appear as the last digit of the multiples of 5? 5, 0, 5, 0, 5, 0, 5, 0. So 5 and 0. F, what 5 digits appear as the last digit of the multiples of 2? 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. So 2, 4, 6, 8, 0. G, if 10 has a multiple of which whole numbers? So which numbers can we multiply to get 10? 1 times 10 equals 10. 2 times 5 equals 10. So 1, 2, 5, and 10. H, on grid paper, draw 2 ways to make a rectangle with an area of 8. Here I can do 4 times 2, that's going to equal 8. I can also do 1 times 8. Oh, I'm sorry, you can't see that. There you go. All right, excellent. Go ahead and put that back in your Tuesday folder, and let's get going on some problems together. the top. Number 1 says Framey bought a toy for $1.85 and sold it for 75 cents more. What price did he sell it? So you got to do $1.85 plus 75 cents more. Go ahead and add those up then. 5 plus 5 is 10. 1 plus 8 is 9. Plus 7 more is 16. 1 plus 1 is 2. $2.60. 6. 6 says, Fadila found the third multiple of 4. Third multiple of 4, 3 times 4 equals 12. Then she subtracted 2 from this number. What was her answer? Minus 2 gives me 10. Flip it on over. Let's do 22. 22 says draw dots and make groups to illustrate 15 divided by 6. So I'm going to draw these in groups of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got 2 groups of 6 and then 3 leftovers. Remember that's 2, remainder 3. Number 23 then. Describe the order of operations in this expression to find the number it equals. Square root of 64 divided by, in parentheses, 4 plus 4. What do we have to do first? The parentheses. So 4 plus 4 is 8. Square root of 64 is 8, so 8 divided by 8 equals 1. 27 is $2.54 closer to $2 or $3? $2 looks at the 5. The 5 says go up 1 time, so it's closer to $3. Same thing then, 2.54 is closer to 3. $28. What fraction of a large square is shaded? You only got 1 of those shaded, so it's 1 out of 100. That would be 0.01. That'd be 1%. Excellent. Good luck on the rest of your problems.